Assalamu alaikum students. Today we start new lecture, complex number. The number of the form x plus iota y, where x and y are real numbers, and I called complex number. Here x is called real part and y is called imaginary part of the complex number. X plus iota y, for example, 3 plus 4 iota. 3 is a real and 4 is imaginary. In 2 minus iota, 2 is real and minus 1 is imaginary. Quotient of iota is a imaginary part. Every real number is a complex number with 0 as its imaginary part. Just like we can write 2 plus 0 iota. 2 is a real number and 0 is imaginary. Next, a question which introduces us to a complex number, x square plus 1. We solve it, x square is equal to minus 1, then taking square of both sides. Minus 1 does not belongs to the set of real number. We therefore, for convenience, call x imaginary number and denote it by iota. Minus 1 square root is equal to small I, which is called iota. The product of a real number and iota is also an imaginary number. Different powers of iota. If iota is equal to minus 1 square root, then iota square is equal to minus 1, and iota cube, it can be written as iota square in dot iota. Iota square is equal to minus 1, therefore iota cube equal to minus iota, and iota 4 is equal to iota square multiplied by iota square. Minus 1 multiplied by minus 1, iota square is equal to minus 1. The product of minus 1 into minus 1 is equal to 1. It means iota 4 is equal to 1. So you can simplify other powers of iota. Some operations on complex number. If we have two complex number like a plus b iota and c plus d iota, and both are equal, then real part is equal to real part and imaginary part is equal to imaginary part. Part 2. If we add a plus b iota plus c plus d iota. If we add two complex numbers a plus b iota plus c plus d iota, real part add in a real part and imaginary part add in a imaginary part. In 3, if we multiply a complex number with any number k, it multiply both numbers real and imaginary. In next, property 4, a plus b iota minus a c minus d iota. At the end you see real part minus real part and imaginary part minus imaginary part. In property 4, a plus b iota multiplied by c plus d iota. We multiply like we multiply the previous examples of two brackets. A multiply with the both numbers C and D, and B iota multiply by both numbers C and D iota. When B iota multiply by D iota, it becomes B dot D iota square, and iota square is equal to -1. So we replace iota square here is by -1. Next, in sixth part, conjugate of a complex number. Complex number of the form a plus b iota and a minus b iota, which have the same real part and imaginary part, differ in sign, only are called conjugates of each other. Like 5 plus 4 iota, its conjugate is 5 minus 4 iota. Only the imaginary part are different in their signs. -2 plus 3 iota, then its conjugate is -2 minus 3 iota. A real number is self-conjugate because its imaginary number is 0. Complex number as ordered pair of real numbers. We can also write it as like a plus b iota, also written as a comma b, and c plus d iota, also written as c comma d. Same properties we solve in previous page with complex sign, and now in a ordered pair form. If two complex numbers are equal, real part is equal to real part, imaginary part is equal to imaginary part. If two complex numbers add in second form, a comma b plus c comma d, real part add in real part, imaginary part in imaginary part. If k multiply by a complex number, k into a, k into b. If two complex number multiply, this is according to the definition of product we do in the last page. Example number 1, sum, difference and product of complex numbers 8, 9 and 5 minus 6. Sum, real part add in real part, imaginary part in imaginary part. Difference, same like sum, real minus real and imaginary minus imaginary. And product, like the last part of above definition, we multiply a by c minus b by d and a by d plus b by c. In order form, we multiply like the above examples. Properties of the fundamental operations on complex number. The additive identity in a complex number is 0, 0. Every complex number AB has the additive inverse minus A minus B. We change their signs. The multiplicative identity is 1, 0, and every non-zero complex number not equal to 0 has a multiplicative inverse. Like Multiplicative inverse of AB is A over A square plus B square minus B over A square plus B square. We derive it in exercise. Next property, distributive property about complex numbers. If we multiply a complex number with a bracket on two complex numbers, the same like the property of distributive property, complex number multiply with the both numbers. Now we start exercise 1.2. First is derive the additive property of the complex number. First property, as you know, we done in last exercise, clear law of addition. If two complex number add, the new number is also a complex number. Next is associative property. Three numbers A plus B plus C plus C, D plus E, F. In ordered pair we write as A, B, and in complex form we write in A plus B iota. So as we solve, the both sides are equal. This property is called associative property of addition. Next property, third property, for all AB belongs to complex number, there exists 0, 0 is an additive identity. Next, for all AB belongs to C, there exists minus A, minus B, additive inverse of each complex number. Question number 2 is same like first question. Now question number 3, verify the distributive law of complex number. So in distributive property, complex number AB multiplied by two complex number in a bracket, it becomes the same result according to the distributive property. We solve this left hand side and right hand side. Calculation lengthy, but it is easy. Now in question number 4, we simplify the power of iota. In first part, power of iota is 9. It is odd number. We take one iota from it and it becomes iota 8. Iota 8 can be written as iota square power 4, and iota square is equal to minus 1. And power of a negative number is a positive number. Next is iota 14. We break it as iota square power 7. Iota square again is equal to minus 1. And odd power of negative number is a negative number. Next is minus iota power 19. Minus iota 19. We simplify it. Power of minus 1. Minus 1, 19 is minus 1 because 19 is an odd number. And we break iota 19 in the form of iota 18 dot iota. Iota 18 can be written as iota square power 9. So we can simplify it like this. Last part of question number 4 is very important. Note it. Minus 1 power minus 21 over 2 and minus 1 is equal to iota square. If power is negative, we make it inverse like 1 over iota 21 and then simplify. At the end we have iota in denominator and then rationalize it. Question number 5 is objective. Minus 1 square root b minus 1 square root is equal to iota, and then minus 5 can be written as iota square root 5 minus 16 over 25. Square root of minus 1 is iota, 16 square root is 4, and then 25 square root is 5. This is like example question number 6, sum of two complex numbers. I think is easy for you. In question number 7, subtraction of two complex numbers. And in question number 8, complete step of multiplication. It is easy for you when we multiply two brackets. At the end we get iota square, and iota square convert into minus 1. Next is division of complex number. Two complex numbers 5 minus 4 iota divided by minus 3 minus 8 iota. We multiply it by the conjugate of denominator, and conjugate of denominator is minus 3 plus 8 iota. It means we rationalize the fraction of a complex number, its conjugate of its denominator, and you know conjugate of denominator, conjugate of a complex number, we change the sign of imaginary number, not the real number, and then multiply numerator by numerator and denominator by denominator. And in denominator we always apply the difference formula a square minus b square and simplify it. Next statement, prove that sum as well as the product of any two conjugate complex number is a real number. Let a complex number a plus b iota. Next is conjugate is denoted by z bar a minus b iota, and we apply the condition sum and product. The sum of complex number is a real number because iota cancel, and product of a complex number also a real number. Sum and product both are real numbers. Next we find multiplicative inverse of each other. As you know, multiplicative inverse of 2 is 1 over 2, and here is minus 4 plus 7 iota. If let it is a z, then multiplicative inverse of z is 1 over z, and then rationalize it, we get the result of its same in the condition 2. In third part, z is equal to 1 plus 0 iota, which is equal to 1. Multiplicative inverse of 1 is 1. Now factorize. This is a tricky a square plus 4b square. We factorize to make a minus between them. You will write a minus and also write in product form minus 1, because it minus multiply minus become plus. In place of plus we can write 2 minus 1 minus is equal to iota square, and then we make its factor a minus b and a plus b. 9a square plus 16b square. Same way we write minus between them and minus 1. In place of plus we can write minus into minus 1. Minus 1 is equal to iota square. Next is 3x square plus 3y square. We common 3 and then make its factor. Same way, same process in 3 part. Question number 16. Simplify. No less we solve second part. It is important. First of all, we simplify the numerator square. Open the square. A square plus b square plus 2ab, and then simplify because in denominator the complex number. We rationalize it. Okay, students, do at least one time each question of this exercise. Thank you and Allah Hafiz.